Rahim. Dear students, today we'll be talking about an important topic, which is the Clausius Clapeyron equation, and also we'll be looking at its derivation, which is very important from the examination point of view. Now, in addition to that, we'll be also talking about its application portion. Okay, so we'll start with the basics of Clausius Clapeyron equation. So we have the definition. So basically a Clausius Clapeyron equation होता क्या है? It's important to understand the phase transitions. ठीक है, number one point. So it's important to understand the phase transitions. Means, for example, if we have a substance, let's say water, which is in the form of solid phase, that means it's ice, and we will supply some energy to this in the form of heat, so it will get converted to the liquid. So now let's say we have this solid liquid equilibrium, ice and water. Okay? So when we supplied the energy, so what has basically happened here, जो molecules के बीच में जो force था, the force between the molecules, water molecules, so that has got disrupted. The force has got broken down. So that means the energy is which we supplied to this system, to this solid phase, that has been utilized in breaking the intermolecular forces. Okay? So so that is with the help of this energy which we have supplied to the system. Now this is a two-phase system. Now it's a one component and two-phase system. इस वन कंपोनेंट और टू फेज सिस्टम में एनर्जी चेंजेस को अंडरस्टैंड करना, व्हेन वी इंक्रीज द टेम्परेचर व्हाट हैपेंस टू द प्रेशर, तो ये सारी चीज़ों को अंडरस्टैंड करने के लिए वी हैव दिस Clausius Clapeyron equation. So it writes that Clausius Clapeyron equation relates the change in temperature. So when we change the temperature of the system, so this will be accompanied by the change in the pressure. Okay? So that means when we heated the system, when we supplied the heat, the temperature has got increased. So this temperature will automatically be accompanied by change in the pressure. Why? Because when the system is in equilibrium, since volume is kept constant, so pressure, we have PV is equal to RT. Okay? So when volume is constant, that means the pressure is directly related to the temperature. If you alter the temperature, pressure will also accordingly alter. So this change in temperature must accompanied by change in the pressure. Okay? When these things are in the equilibrium. For example, here we have one component system, two phases. So this change in pressure due to change in the temperature, so that is directly related to the enthalpy of the system. ये कैसे related है to the enthalpy of the system? This we'll see when we'll go to the derivation. So, but in general, what Clausius Clapeyron equation does, it relates the change in temperature with the change in pressure, and also it relates this temperature change and pressure change with the enthalpy of the system. Okay? And is useful to understand the phase transitions. Okay? So, for example, here we have some substance which is in the phase A, and that same substance is in the phase B. So when we have the two systems in the equilibrium, so the free energy of molecules in this is equal to free energy of the molecules here. ठीक है? So इस सिस्टम को अंडरस्टैंड करने के लिए जब हमने टेम्परेचर को रेज किया तो कितना चेंज फेज हो गया, ठीक है? So how it will affect the free energy of the system, so that whole process will be governed by it will be understood with the help of Clausius Clapeyron equation. ठीक है? इसको अंडरस्टैंड करने के लिए बेसिकली इसमें जो इंपॉर्टेंट पोर्शन है, दैट इज द डेरिवेशन. सो लेट अस गो टू द डेरिवेशन. सो विल स्टार्ट विद द डेरिवेशन दैट हमारे पास एक सिस्टम है विच इज द इक्विलिब्रियम. दिस इज आवर सिस्टम. वी हैव टू phases of a substance, a pure substance. We have two phases of it. ठीक है? Let's say this is solid phase, this is liquid phase, for example. So this is phase A, this is phase B. तो इसमें जो molecules होंगे, molecules present here, So obviously they will be having some free energy. Let's say the free energy Ga, and the molecule is present here, the amount of substance present here, that will be having free energy Gb. Now as the system is in the equilibrium, obviously the change in free energy is zero. So whenever we have the substances existing in equilibrium between the two phases, the free energy is obviously zero. So यहाँ पे point number 1, free energy is zero. Now उसके बाद क्या लिखा है यहाँ पे, also the variation of free energy change with the temperature and pressure is given by. Now we'll try to understand. We'll vary the temperature here. Initial pressure was P, initial temperature is T. Now we'll try to vary the temperature. When we will vary the temperature, then we'll try to understand how the pressure will go and then how the energy of the system varies. Okay? So now we'll apply this, that Gibbs free energy equation. We know this equation, that delta G is equal to H minus Ts. That's the free energy of system is equal to enthalpy minus temperature and entropy. ठीक है? उसके बाद जब हम इसमें अप्लाई करेंगे ये वाली इक्वेशन, दैट एंथैल्पी इज इक्वल टू इंटरनल एनर्जी प्लस पीवी. ठीक है? एंड विल यूज दिस रिलेशनशिप दैट चेंज इन द heat, it's basically this dq. So we can correct this dq, small dq. That is, we know that heat change by the temperature is equivalent to change in the entropy. क्योंकि जितना हम किसी भी substance को heat करेंगे, its entropy will automatically get changed, it will increase. So that means delta dq is equal to TdS. So this is dq is equal to TdS. You can correct this. So this is basically this. तो जब हम ये वाला relationship and this dq is equal to TdS, if we apply in this Gibbs phase, this is Gibbs free energy equation, and then वहाँ जो हमें value मिलेगा, then we'll do the integration of that. We'll end up with a relation that is dg is equal to vdp minus sdt. ठीक है? So this is our main relation जहाँ से हम Clausius Clapeyron's equation को हम derive करेंगे. I hope कि आप इसको कर लोगे. What you need to do is that you take this G is equal to H minus Ts. इसमें put the value of H is equal to E plus PV. उसके बाद क्या करना है आपको, that dq is equal to TdS. dq, so you can write dq is equal to TdS. Now the question is that where from this will come? What is the importance of dq is equal to TdS? Basically ये जो आपको मिलेगा, for example when you put this value of H is equal to E plus PV in this relation, so वहाँ से what you will get let me write it here. You will get G is equivalent to E plus PV minus TS. ये जो आपको relation मिल गया, you have to do the differentiation of this. When you do the differentiation, then you can use this dq as equal to TdS. You will finally end up with this relation. dg, change, small change in the free energy, is product of volume and small change in the pressure minus entropy and small change in the temperature. ठीक है? So please remember this relation. This is very very important relationship for solving many numerical problems. dg is equal to vdp minus sdt. ठीक है? Now इससे हम derive करेंगे Clausius Clapeyron equation. So now let's consider a pure substance in phases 1 and 2. ये दो phases है. A pure substance which is present in the phase A and phase B. They are in equilibrium at a temperature T. So that means when the phases are in equilibrium, the free energy is also the same. ठीक है? So that means the change in the free energy will be equivalent to 0. Or we can arrive at the conclusion, the free energy of the substance in G1 is equal to free energy of substance in G2. Or you should say, यहाँ पे you can write GA rather, subscript A, because यहाँ पे diagram is subscript A, and you can write this as GB. ठीक है? So need not get confused. Or you can keep it as G1, G2. So then take this A as 1 and keep this B as 2. ठीक है? Now GA is equal to GB or G1 is equal to G2. If the temperature of system now उसके बाद हम क्या कर लेते हैं? Now let's say we increase the energy of system. We'll supply the heat. So that means the temperature is increased from T plus dt, that is with a small change in temperature. जैसे मैंने कहा system is in the equilibrium. For the system to remain in the equilibrium, the pressure will also get altered accordingly. So let's say the pressure changed from P to P plus dP. ठीक है? So when the pressure changed, so we can write down now dg1 for substance 1 as per this relation. It's V1 dP plus S1 dt. For substance 2, not substance 2, for the material, for this substance in the phase 1 and for substance in phase 2, or you can write down the substance in phase A and substance in the phase B, क्योंकि हमारा जो substance है that is same, we are only different phases. So दो phases के लिए you can write down these two equations. dg is equal to vdp minus sdt. ठीक है? आप ये क्या ये कर सकते हैं, you just keep this one rather than GA and this you keep it G2. That will make our work easy. ठीक है? So now up to this we have done. Let's move the next. Now ये हमने already understand किया at equilibrium G1 is equal to G2. So इसका मतलब change in G2 is also equal to change in G1. जब free energy same होगी तो उनकी जब हम temperature vary करेंगे उसमें जो change in free energy होगी वो भी same होगी. Then only system is at equilibrium. So that means हम दोनों को correlate करेंगे. So we'll go back one bit. So ये जो दो relationships है, will when this is equal to this, so your left hand sides are equal, that means the right hand side are also equal. So we'll write down that V1 dP minus S1 dt is equal to V2 dP minus S2 dt. ठीक है? उसके बाद हम क्या करेंगे, दिस इज V1 dP, जो प्रेशर वाले टर्म्स है उनको हम एक साइड में लेके आ जाएंगे. फॉर एग्जाम्पल यू ब्रिंग दिस हेयर, जो टेम्परेचर टर्म्स है उनको यहाँ पे लेके आ जाएंगे. ठीक है? एंड देन यू टेक V1 एंड V2 हेयर, उसमें प्रेशर को आप कॉमन ले जाओ दो में से, so it becomes dP V1 minus V2. Likely यहाँ पे आप क्या करोगे, you take this change in temperature common and then you will end up with this relation. And now we can write V1 minus V2 is change in volume. जब आपने टेम्परेचर सिस्टम का वेरी किया फ्रॉम V1 to V2, so जब आपने टेम्परेचर चेंज किया सिस्टम का फ्रॉम T1 to T2, the volume accordingly will be V1 and V2. So change in volume is delta V. So this is delta V into pressure. Likely change in the entropy, because entropy of system increases with increase in temperature. So the change in entropy is equivalent to delta S. So we write down dP, इसको हम यहाँ पे लेके आ जाएंगे divide. So this will go on this side. ठीक है? So dP by dt is equal to delta S by delta V. So this is basically delta S is molar entropy change. ये molar means हमने जो substance लिया है that is 1 mole of substance. उस 1 mole of substance को जब हमने स्टडी किया, हमने टेम्परेचर को रेज किया है फ्रॉम T to dt, प्रेशर ऑटोमेटिकली चेंज फ्रॉम P to dP. Now इसमें जो एंट्रोपी चेंज होगी दैट्स कॉल्ड 1 मोल चेंज इन एंट्रोपी. ठीक है? सो दैट्स कॉल्ड एज मोलर एंट्रोपी चेंज. लाइकली जो चेंज वॉल्यूम में हुआ है दैट इज मोलर वॉल्यूम चेंज. नाउ ये दिस इज वन फॉर्म ऑफ कैलेप्लॉन इक्वेशन. This is one form of Clausius Clapeyron equation, shortcut. That is dP by dt is equal to delta S by delta V. Now, if the enthalpy H is the latent heat of transformation, जैसे हमने solid को convert किया into liquid, ठीक है? इसमें heat इसने absorb की. For example, if it's solid convert to liquid, it's called enthalpy of fusion. ठीक है? If it is liquid to vapor, it's called enthalpy of vaporization. If the conversion is from solid to gas, it's called enthalpy of sublimation, latent heat. ठीक है ना? Then what will the entropy किसके बराबर होती है? Change in the enthalpy divided by temperature. ठीक है? अब ये जो relation है, we will apply now this relation here. So what you will get dP by dt is delta H by dV. This is your Clapeyron equation. That is variation of pressure with respect to temperature. So it is directly proportional to the enthalpy and it is inversely proportional to the change in the volume multiplied with the temperature. ये होगी एक form of Clapeyron equation. ठीक है? Now इस Clapeyron equations को हम further understand करने के लिए we'll try to do something. We'll apply this for liquid gas equilibrium. Means हमारे पास let's say we have water in the liquid form. ठीक है? And then this is in equilibrium with our water at which is your vapor. ठीक है? तो इसको हम अप्लाई करने की कोशिश करेंगे. द Clausius Clapeyron इक्वेशन कैन बी रिटन एज चेंज इन प्रेशर विद चेंज इन टेम्परेचर एंथैल्पी. यहाँ पे वॉल्यूम हम चेंज करेंगे आप. दिस इज वेरी इंपॉर्टेंट. दिस इज, इसको हम कंसिडर करेंगे इसका जो वॉल्यूम, दैट्स वॉल्यूम ऑफ गैस. दिस इज वॉल्यूम ऑफ लिक्विड. सो दिस इज वॉल्यूम ऑफ गैस माइनस वॉल्यूम ऑफ लिक्विड. यानी जो आपका Clausius Clapeyron इक्वेशन इज चेंज इन वॉल्यूम, आपको ये एडजस्ट करना पड़ेगा अकॉर्डिंगली. इफ इट इज मेल्टिंग ऑफ आइस देन यू टेक वॉल्यूम ऑफ लिक्विड माइनस वॉल्यूम ऑफ सॉलिड. ठीक है. So we can write down it like this. Now since the volume of liquid is very small as compared to volume of vapors, अगर हम एक given 1 mole of substance को ले लें, then we will compare the volume of the same substance in the liquid phase and volume of same substance in the vapor phase. तो obviously vapor में molecules are far apart, तो volume बहुत ज़्यादा होता है. So that means जो liquid का volume है that is very very small as compared to the vapors. So that means liquid जो है उसका volume is very very less than the volume of your gas. So that means this can be neglected. So अगर हम ये term neglect कर लेंगे, so it becomes dp by dt is enthalpy by tvg. ठीक है. Now if we apply the ideal gas equation, यहाँ से हम vg का वैल्यू निकालेंगे. ठीक. So that we will put here vg. So you will end up with the relationship, this relationship. Now it is 1 by p dp by dt. अब यहां पे एक इंपॉर्टेंट चीज है कि 1 by p into dp. इसको आप याद रख लीजिए. दिस इज मैथमेटिकल रिलेशन. दिस इज कॉल्ड d ln of p or d natural log of p. ठीक है. So that's what I wrote, d natural log of p divided by dt, that is equal to delta v, that is enthalpy of vaporization, change in मोलर चेंज इन द एंथैल्पी ऑफ वेपराइजेशन. ठीक है. यानी जब आपने लिक्विड को वेपर में कन्वर्ट किया, फॉर एग्जांपल वाटर को वेपर में कन्वर्ट किया, वहां पे जो एंथैल्पी चेंज है दैट्स कॉल्ड चेंज इन द एंथैल्पी ऑफ वेपराइजेशन डिवाइडेड बाय आरटी स्क्वायर. तो ये बहुत इंपॉर्टेंट रिलेशनशिप है, इसको आप रखिए. दिस इज आल्सो कॉल्ड एज अनदर फॉर्म ऑफ Clausius Clapeyron इक्वेशन. नाउ इसको when we practically utilize this, it's very difficult, so it's better we'll convert this into the straight line equation. How can we do this? इसके लिए यहाँ पे देयर इज अनदर फॉर्म कॉल्ड द लॉगरिथमिक फॉर्म ऑफ Clausius इक्वेशन. ये जो नेचुरल लॉग है दैट इज ln ऑफ, राइट दिस l, इट्स कॉल्ड ln और नेचुरल लॉग. ये होता है बेसिकली टू द बेस e एक्सपोनेंशियल. इट इज इक्वल टू 2.303 log to the base 10. Now if you want to write this in the form of log to the base 10, so this is equivalent to 2.303 log to the base 10. So जब हम इसको convert करेंगे then we'll get this relation. So it was basically यहाँ पे 2.303, वही 3 हमने इसको यहाँ पे divide किया है. So you will get this relationship. ठीक है. Now ये जो relationship है it's called relationship of the equation of straight line. ठीक है. So when you call the equation of straight line, this is your y, this term is your y, this is your m, this much. So that means you have write it here. So it's y is equal to mx plus c, equation of straight line. So y is your log of p, that is equal to slope is your minus delta, that m is equal to, it's called slope, delta h by 2.303 r. ठीक है. x इसका वेरी कर रहे हैं, that is 1 by t. So this x was 1 by t plus constant c. So that means when you plot a graph between this natural log of p versus 1 by temperature, so आपको जो graph मिलेगा that will be straight line graph like this. This is your log of p, this is temperature, so you'll get a graph like this. उस graph का अगर आप slope निकालेंगे, say this is slope, that slope will be automatically equivalent to this much. जैसे यहाँ पे भी आ रहा है, this is called m. m means slope, that is delta h by 2.303 r, this term, this is your slope. ठीक है. तो slope आपने निकाल दिया, तो slope की हेल्प से you can easily calculate the enthalpy of the enthalpy of vaporization of this phase transition when you convert solid to the vapors. ठीक है. Likely आप किसी भी सिस्टम का, फॉर एग्जाम्पल अगर आप स्टडी कर रहे हो बिटवीन, दैट इज यूर स्टडीइंग द मेल्टिंग ऑफ आइस, दैट इज देन दैट बिकम्स द एंथैल्पी ऑफ फ्यूजन. तो आप एंथैल्पी ऑफ फ्यूजन कैलकुलेट कर सकते हो. लाइकली एंथैल्पी ऑफ योर sublimation you can calculate with the help of this curve. Now agar aap you can further try to understand the effect of pressure on the temperature. So aap kya karoge, you use the same relationship at two different temperatures. That means automatically you have two different pressures. So wahan pe you can use the integrated form of Clausius Clapeyron equation. That is, if you vary the, if you have a system at, you steady have at one temperature, that is T1, then you change the temperature, that is T2. So T1 और T2 के बीच में obviously the pressure will also change according to be P1 and P2. So if you want to relate that P1 and 2 with respect to T1 T2, this is the relationship you can use. That is log of P2 by P1 is equal to minus enthalpy of vaporization by 2.303 R and bracket 1 by T1 minus 1 by T2. This is our Clausius Clapeyron equation. There are different forms, different expressions. ठीक है, they have their utility. So the aim is that अगर आपके पास कोई भी phase transition हो, you can correlate pressure, temperature and enthalpy through different ways. ठीक है, and then particularly अगर आप, if you are doing some experiments, then this relationship is useful, this one, logarithmic form, because it is a straight line equation. ठीक है, slope से आप आराम से निकाल सकते हो the enthalpy change in the reaction, depending on it is vaporization or enthalpy of fusion or enthalpy of sublimation. So you can do that. ठीक है. Now let's move to the last point, that is the application. So application क्या है इस Clausius Clapeyron equation की? Number one, calculation of molar heat of vaporization in this case. You can also write calculation of molar heat of fusion. कैसे? if you, अगर आप इस equilibrium को study कर रहे हो या इस phase transition को, that is solid to liquid, so then you need the heat, that's called heat, the enthalpy of fusion. ठीक है. So you can also calculate the enthalpy of fusion. This is for this heat, molar heat of vaporization. It's for when you are studying the phase transition between liquid and vapor. ठीक है. You can calculate the molar heat of vaporization. Molar यहाँ पे it means we are taking 1 mole of substance. Remember this. Likely we can calculate effect of temperature on the pressure. जैसे मैंने यहाँ पे कहा, अगर आपने ये वाली Clapeyron equation ली है, ये वाली P1 P2, ठीक है, प्रेशर कैसे वैरी होगा विथ रिस्पेक्ट टू टेम्परेचर, या यहां से भी अंडरस्टैंड कर सकते हो, जब आपने टेम्परेचर को वैरी किया हाउ द प्रेशर वैरीज, वो भी आप स्टडी कर सकते हैं. तो यू कैन कैलकुलेट द इफेक्ट ऑफ टेम्परेचर ऑन द वेपर प्रेशर. एंड थर्ड पॉइंट, यू कैन आल्सो कैलकुलेट द इफेक्ट ऑफ प्रेशर ऑन द बॉइलिंग पॉइंट. इसको हम थोड़ा सा फ्यू मिनट्स में डिस्कस करेंगे. देखिए हमारी जो रिलेशनशिप है दैट इज दिस वन, log of P is equivalent to, let me write this. So you have log of P is equivalent minus delta H divided by 2.303 R, and this is 1 upon T, ठीक है, plus constant. अब यहाँ पे since this is constant, इसको हम अभी ऐसे ही रख लेते हैं. So let's say this is log of pressure versus temperature की relation क्या है? इनवर्स. लेकिन इनवर्स में आपका नेगेटिव भी है यहाँ पे. That means your log of P is directly related to temperature. So that means अगर कहीं पे now if you are studying liquid and vapor system, that means if you are studying liquid and vapor system, so liquid को vapor में convert कर रहा है, that means वो जो temperature होगा that will be the boiling point. So this it can be called as the boiling temperature. That means जो boiling point है it depends on the pressure. So अगर कहीं पे pressure decreases, that means the boiling point of liquid also automatically goes down. That is what happens at the high altitudes, that when the pressure decreases, the liquid boils at low temperature, so the boiling point decreases. So that means we can calculate the effect of क्यों boiling point क्यों decrease होता है, क्योंकि pressure decrease हो जाता है. So with the help of Clausius equation, Clausius Clapeyron equation, we can also understand the effect of pressure on the boiling point of the liquid. ठीक है. So this is all about today's class. We'll go back. So what we have first done is the what do you mean by the Clausius Clapeyron equation? So it is used to understand the phase transitions. It relates the change in temperature with the change in pressure and also with the enthalpy of the system. Okay, and then derivation के लिए we'll use this dg is equal to vdp minus sdt. You can remember this very important relation. dg is equivalent vdp minus sdt, where dg is change in the free energy, v is the volume, dp is change in pressure, s is the entropy, and d E is the engine temperature. इसको मैंने कहा you can derive by using these three relations. ठीक है, and then to derive this हम क्या करते हैं, हम दो systems को लेते हैं, हम थोड़ा सा temperature change कर लेते हैं इसमें. We'll go from T to dt. Pressure will also automatically change for the system to remain in the equilibrium. So the pressure will go from P to dP. ठीक है, तो वहां से आप दो relations बना लेते हो, this one and this one. And then next what you do, since the free energy change is zero, so you correlate the right hand side is called left hand side, so this is called this. यहाँ से you can derive this relationship, which is called as your Clausius Clapeyron equation. You can write this in terms of enthalpy change, this one. So this is one expression of Clausius Clapeyron equation. Then you can write another expression in terms of natural log. You can write one more expression as the logarithmic form, and then you can also write this between two different temperatures and pressures. These are all different forms of Clausius Clapeyron equation. And then finally you can try to get the information like calculate the molar heat of vaporization, effect of temperature on the pressure, and effect of pressure on the boiling point. Okay, so I hope you understood this class. If you have the questions or any clarification, you can write down in the group, or you can write down the comments also. ठीक है, इसके अलावा ये जो मैंने पढ़ाया इसका ये जो नोट है, शॉर्ट नोट, so this will be also in the description, so you are free to download this. आप इसको डाउनलोड कर सकते हो. ठीक है, so thank you. This is all about today's class. So we'll end up class here. Thank you.